So in this session, we will discuss the exercise related to periodic table, the multiple choice question mainly. In the first question, so where in the periodic table is the metallic character of element is greater, like where we'll get more metallic character or tendency of the metal to lose electron is more. So as we move, when we check the periodic table, like we have group 1, we have group 1, group 2 is there, then transition element, then group 3, 4, 5, 6, 7, and 8. So here we will find mostly metals. On the right hand side, we will find mostly non-metals. So which position likely will find metals on the left or on the right? So on the left hand side, we'll find mostly metal. And as we go down the group, what happened to metallic character? It increases because down the group, as we go down, the size is increasing, size of the atom as it is having more shells. The first will have 2, like example, then 3, and then 4. So more shells are there, so these elements have a tendency to lose electron easily. That's why on the left hand side, the element will be more metallic, and at the bottom of the periodic table, the element will be more metallic. So left or right side of a periodic table, where we'll find at the left, and at the bottom or top we'll find more metallic. At the bottom we'll find more metallic because the size of atom is greater. So as the size is larger or greater, then it can lose electron easily. That's why it will be more metallic. So on the left and the bottom, that is why A is the right answer for this. Is it clear, this question? Then in question 2, some properties of 4 elements P, Q, R, and S are shown. 2 of these elements belongs to group 1 and 2 of the elements belongs to group 7. So this is a description given. P react with water, P react vigorously with water. So if it is reacting vigorously with water, because group 2 metals, or also known as alkali metal, they have a vigorous reaction. So it means this is group 1. Then does not react with water. So if group 7 does not react with water, so this is group 7. And react explosively. So R is also reacting with water, so it gives an idea that is group 1. And S dissolve to give a colored solution, and it is liquid. So group 1 are all solid. So group 7 first 2 are gas, then liquid, and then solid. So it means S is group 7. So when we work out which 2 elements are there in group 1, so we have the 2 elements which are group 1, P is there in group 1 and R is there in group 1. And when we check the elements in group 7, which 2 elements are there in group 7? So it means Q is there in group 7 and S is there in group 7. Now, how to identify their positions? One is reacting vigorously and another one is explosive reaction. So if it means R is more reactive and relatively P is less reactive. And as we go down the group for group 1, what happened to the reactivity? As we go down the group, the reactivity increases. So it means R is more reactive and P is less reactive, because it is vigorous reaction, but for R it is explosive reaction. So it means P is above R. In the group, P is above R because R is more reactive for group 1. As we go down, the reactivity increases. So R is reacting explosively and P is reacting vigorously. And about group 7, as we know for group 7 about the state, because here in terms of reactivity we cannot identify, we can identify in terms of, even if you mention reactivity, but here's a physical change. So in terms of group 7 we can identify from state that first two are the gases, like fluorine and chlorine are the gas, then it is liquid, and then solid. So as we go down the group, the state is, the melting point is increasing and state changes from gas to liquid to solid. So which we know group 7, Q and S both belongs to group 7. So Q is their group 7 and S is their group 7. But how to identify the position? As you can see, Q is solid. So solid is below. In group 7, the solid state is below and a liquid state is above. So it means when we work out the position, so it will be S will be above Q. So this is how we locate their positions in the group. Now we check which statement is correct. P is below R. You can see P is not below R. That's wrong. Q is above R, but Q and R does not belongs to group 1, so that's totally wrong. Q is below S, so Q is below S, and in group 7 both belongs to group 7, so statement C is the right one. And R is below S, so R and S are not in the same group, that's why it is not the right statement. So C is the correct answer for this. Is it clear how we work out the position of these elements in their group? For group 1, we work out in terms of reactivity, and group 7 we work out in terms of state. Then which of the following could be a transition element? What are the characteristics of the transition element? Number 1, they should have high melting point. They should have high density. They should be colored, or their compounds are colored, and electrical conductivity. Yes, they should conduct electricity. So we check high melting point. So C and D both have the high melting point. High density as well. So when we compare the density, which is having a high density, so 4.5 is high density compared to 2.3. So it means it cannot be D, it means it will be C. And it is a colored, yeah, that's right. And they, all metals are conductor of electricity, they can conduct electricity, that's why C is the right answer. So which is the characteristic of, a common characteristic for these transition elements. Is it clear? Question 3, that how we work out which could be a transition element. So these are the basic characteristic of the transition element. Which two statements about the argon are given. Argon is having a full outer shell. Argon belongs to group 8, or we also call 0 group. So it belongs to group 8. So it will have a full outer shell. That's 2. And group 8 are unreactive, but here it is written it is very reactive. So it means this statement is not, it is used in lab, that is correct, but it is not very reactive, it is unreactive. Group 8 are unreactive because they have a complete shell. So when we check both statements are correct, this is wrong, both statements are not correct, both statements are not correct for B as well. Statement 1 is correct, but the statement 2 is incorrect, that's why C is the right answer. Then where in the periodic table metallic character, what is the meaning of metallic character? Means they will have a tendency to lose electron easily. So where in the periodic table we'll find? So on the, when we check the periodic table, on the left hand side of a periodic table we have metals. On the right hand side of a periodic table we have non-metals. So where, So we will find metals on the left. And down the group, when we go down, what happened? Because the size of the atom is increasing as there are more shells. As there are more shells, the size is increasing, so it can lose electron easily. So they will become more metallic. So down the group, they become more metallic. So at the bottom of the group, they are more metallic, and on the left hand side of the periodic table, they are mostly metallic. That's why A is the right answer. And this was a repeated question. Question 1 was the same question. Rubidium is a group 1 metal, and group 1 metal in exam you will have the periodic table, so you can check the periodic table. Like periodic table include lithium is there, then sodium group 1, lithium, sodium, potassium, rubidium, cesium, and francium. This is all alkali metals because when they react with water, they give a makes alkali, produce a hydroxide and hydrogen gas. So and as we go down the group, what happened to reactivity? The reactivity increases for this group. What happened to the melting point? The melting point decrease, and when we check the options, which is not correct, it has higher melting point. And about the density, when we check the density increases as we go down for all the groups. It has higher melting point than lithium. Rubidium is below and lithium is above. So when we move from lithium to rubidium, the melting point decreases. But in the option, they're saying it is having a high melting point. So it means A is not the correct statement, or A is wrong. It has one electron in outer shell. That is true for all, because the group number represents the number of electron in the outermost shell. So lithium will have one electron. Rubidium will also have one electron. It reacts vigorously with water because as we go down, the reactivity increase, so vigorous or explosive reaction occur. It reacts with chlorine to form rubidium chloride, RbCl. That's correct, because rubidium is group 1, so it has a valency of +1. Chlorine belongs to group 7, which is having a valency of -1. So when we cross multiply, rubidium chloride will be RbCl. So that is a correct formula. So A is the right answer, which is not the correct. Rest other statements are all correct. Is it clear? Question 6. Then the tables give information about 4 elements P, Q, R, and S. For to be a transition, they're asking which could be a transition elements. So it should have high melting point, it should have good conductivity, it should have a high density, and colored of iodine, it should be colored. They should form a colored compound. So first thing, high melting point when we check, so 98 and -39 is a very low melting point. So we are left with two options, R and S. But when you check electrical conductivity, all metals are good conductor. Then they have high density and it will form a colored compound. So it means it is S is the only transition element in this table. That's why D is the right answer. Is it clear why S is a transition element? Because to be a transition element, it should have a following characteristic: high melting point, high electrical conductivity, high density, and it should form a colored compound, or its compound or element both can be used as catalyst, speed up the reaction. The part of the periodic table is shown. Which element is gas that does not form a compound with potassium? Does not form a compound with potassium, it means no reaction, does not react. So first thing, A is group, C is group 2, group 2 are all solid. It's not gas. When we check, this is group 3, 4, 5, and this is group 6. So this group 6 will be a gas, a non-metal, but it will react. When we check D, D is group 7. This will also be a gas, but it will react because group 7, group 6, they all are reactive. But when we check B, B belongs to group 8, and group 8 are known as noble gases as they have a complete shell. So B won't react. That's why B is the right answer for this. So unreactive gas or does not react, that is B. Then which statement about elements in group 1 is correct? Hydrogen is evolved when they react with water. Yeah, that is correct because when they react, like example, if lithium react with water, as a result, it will produce lithium hydroxide plus hydrogen. Sodium metal react with water, sodium plus water. As a result, it will produce sodium hydroxide plus hydrogen. Potassium react with water. As a result, it will produce potassium hydroxide plus hydrogen. So all of them are giving off hydrogen. That's A is the right answer. What about other options? Ions of group 1 element have charge -1. That's wrong. They all have a charge +1. They should, because they lose electron. So charge. Sodium is more reactive than potassium. That's wrong. Because as we go down the group, the reactivity increases. So it means sodium is less reactive compared to potassium. And solid sodium is poor conductor. That's wrong. All metals are good conductor of electricity. So all can conduct electricity. Then osmium is a transition element. Transition element. So what about the melting point? The melting point should be high. What about the density? It should be high. And colored compound. Yes, the compound should be colored. So melting point is high, density is high, and it is forming a colored compound. So A is the right answer for this. In question 11, two statement about the noble gases are given. Noble gases are reactive. That's wrong. They are monoatomic, but they are not reactive. So this statement 1 is wrong. And noble gases all have full outer shell electron or all have complete shell. That is true. So statement 1 is wrong. Statement 2 is correct. So statement 2 is correct, but statement 1 is incorrect. That's why D is the right answer for this. Then question 12, some properties of substance X are listed. Like there is substance X, it conducts electricity when molten. So it means this is a property which is happening for both ionic compound, because ionic compound can conduct, or it is for metals as well. Metals can also conduct. It is having a high melting point. So this also means it can be ionic because ionic compounds have high melting point, or it can be a metal. And it burned in oxygen. Ionic compound cannot burn. Ionic compound can dissolve but does not burn. So it means this substance is a metal. Like metal can burn or metal can react with oxygen and then form a basic oxide. So what could be this? Because according to option, either it will be ionic or metallic, but the third part shows it is a metal. So C is the right answer. It cannot be covalent compound because covalent compound cannot conduct electricity. Macromolecules cannot conduct electricity except for graphite. Even graphite can conduct at solid state. And ionic compounds can conduct electricity in a molten, and ionic compounds have high melting point, but ionic compound does not react with oxygen or does not burn in oxygen and give a pH of a solution 11. What does it mean? Like example, if any metal is there, say sodium or magnesium react with oxygen, give magnesium oxide, and that magnesium oxide dissolve in water to give magnesium hydroxide, which make a solution alkaline. So C is the right answer because ionic compound does not burn in oxygen. Only metal can react or burn in oxygen. This is related to identification of the ions. So a substance X is warm with hydrochloric acid and it produces a gas which decolorizes potassium manganate. So this is basically when we add hydrochloric acid and heat. So this is a test for sulfite ion. So it means this shows that there is a sulfite ion. And substance X give a yellow flame. So in a flame test, if it's a yellow flame, it means there is a sodium. So it means it contains sodium and this test shows it contains sulfite. So what is the compound present? It contains sodium sulfite. So this is related to memorization. Once you memorize these tests for the ions, directly you can answer these type of questions. Which element is less reactive than the other member? So when we check about, because cesium and rubidium are group 1 elements and fluorine and astatine are group 7 elements. So this is group 7 and this is group 1. For group 1, when we compare the reactivity, so the reactivity increases as we go down. So they become more reactive. So elements which are at the bottom, like rubidium and cesium are there at the bottom, so they are more reactive. But for group 7, so we have rubidium is there, cesium, they are more reactive compared to other members like lithium is there, sodium is there, potassium is there. And when we check for group 7, as we go down the group, what we observe the reactivity decreases. They become less reactive. So we have fluorine more reactive than chlorine, chlorine more reactive than bromine, bromine more reactive than iodine, and iodine more reactive than astatine. So which is a less reactive? So when we check, astatine is a less reactive in its group. That's why A is the right answer. Then elements in group 4 of the periodic table are shown: carbon, silicon, germanium, tin, lead, and fluorium. What does not occur in group 4 as we descend? Like as we go down the group, what does not happen? The proton number of element increases, that is true. Like elements which are at the top of the periodic table, top of the group, they have lower proton number or atomic number as compared to elements at the bottom. So this is true. The elements become more metallic. Yes, as we go down, they will become more metallic. Like carbon, silicon are less metallic or they are like metalloids. Carbon is a non-metal, germanium, silicon are metalloids, and then tin, lead are, these all are metal. So at the top we have non-metal in this group and at the bottom we have metals. So it become more metallic as we go down, that's true. The elements have more electron in the outer shell, that is wrong. Why? Because as I mentioned, they belongs to group 4. So if element belongs to group 4 means they all have 4 electron in the outermost shell. And the elements have more electron shell, that is true. Because as we go down, the number of the shell increases as the period changes. So there will be more electron shells available. That's why D is also right, but the option C is not correct because as they belong to group 4, they should have 4 electrons in their outermost shell. Is it clear? Then in question 16, Why are weather balloons sometimes filled with helium rather than hydrogen? Because hydrogen is a reactive gas and helium is unreactive. And in terms of density, when we compare their density with, like, compare the density of hydrogen with helium, hydrogen is having a low density and helium is having a high density compared to each other. But when we compare with air, when we compare the density with air, both have low densities. So the density of hydrogen and density of helium both are lower as compared to air. So helium is found in air, but that's not the reason why we use. Helium is less dense than hydrogen. That is wrong. Helium is more dense or high density than hydrogen. Helium is more dense than hydrogen. This is true. But that is not the reason why we use it for weather balloon. We use it for weather balloon because it is unreactive. So statement C is correct, but that is not related to the explanation that why it is used in weather balloon. Why not hydrogen? Because hydrogen is a reactive gas and helium is unreactive. That's why we use helium in a weather balloon. Then metal X is added to colorless solution of aqueous solution of Y. So metal X is there and it is added to Y sulfate. This is colorless. So if a compound is colorless, if metal compound is colorless, it means it is not a transition element. Because transition element, there should be a colored compound. And what happened? A colored solution is formed and a metal Y is deposited. It means X is more reactive, X displaces Y. So as a result, what happened? As X displaces Y, so it will form X sulfate, which is a colored solution, and it produces metal Y. So colored solution means this is it contain a transition element. So the question is type of element, which is a transition element, because the substance X compound is a colored compound, so it means X is a transition element. And when we compare, because there is a reaction, so an element X is added to Y, so compound of Y, because there is a reaction, so it shows that X is more reactive than Y. So A is the right answer, that X is more reactive than Y. That's why X is able to displace Y from its compound, as well as X is a transition element because X was having a colored compound. Is it clear? Question 17. So dilute sulfuric acid is added. Again, this is related to identification of the ions, the last part of acid topic. The dilute sulfuric acid is added to solutions, solution X and Y. The observations are there. Which row shows the ions present? When solution X, when we add sulfuric acid to solution X, a white PPT is there. So basically, what is the reason for white precipitate? It means the solution X contain a barium ion. Because when barium ion reacted with sulfuric acid or sulfate ion, as a result, it will produce barium sulfate, and barium sulfate is a white PPT. So it means solution X contain a barium ion. And when we add to solution Y bubbles of colorless gas, so it means when acid is added, which case acid is emitting out a gas, if it is reacting with carbonate or a metal. So two ways are there. Acid can give out gas. Acid react with metal, it give hydrogen gas, and acid react with metal carbonate. So it means it will give carbon dioxide. So metal can be any metal is there in solution Y, any metal. but there is a carbonate present, CO3. Acid react with carbonate will give us salt and carbon dioxide. So due to the carbon dioxide, we'll see bubbles, phase or effervescence. So solution Y is a carbonate, contain carbonate, and solution X contain a barium. So again, this is related to memorization. You have to learn these results for the ions. Which element is less reactive? It's a repeated question. Astatine, group 7 is less reactive. The element oxygen and sulfur are in the same group. So if element belongs to same group, like oxygen is there and sulfur. Which statement about oxygen and sulfur not correct? Oxygen is 8 and 16 and sulfur is 16 and 32. So oxygen electronic configuration, first shell it will have 2 electrons, second shell it will have 6 electrons. For sulfur, first shell 2, second shell 8, and third shell 6 electron. Because they belong to same group, so they should have same electron. They are non-metal, that's true. They have a giant covalent structure. They don't have giant covalent structure. That is not the right statement. They have 6 electron in the outer shell, that's true. And they react together to form acidic oxide or non-metal oxide. That's true because sulfur react with oxygen gives sulfur dioxide, and sulfur dioxide is a non-metal or acidic oxide. So statement B is not correct, that they have a giant covalent structure. This is valid for group 4 elements like carbon, silicon. They can form giant structure, not for group 6. Why in a weather balloon we use helium? Because helium is unreactive. This is a repeated question. It does not react. That's why we use helium rather than hydrogen. This is related to identification of the ions. When we add sodium hydroxide to compound Y, it give a green precipitate. When we add aqueous ammonia, it also give a green precipitate. In each case, the precipitate is insoluble. Precipitate does not dissolve. So what could be? Because the green precipitate, there are two ways. There are two reasons why there is a green precipitate. One is due to chromium. Another one is due to iron 2. So iron 2 precipitates, iron 2 when it react with sodium hydroxide, green precipitate, or chromium when it react with hydroxide, green. But for chromium, the precipitate dissolve in aqueous sodium hydroxide. But in case of iron, the green precipitates are, so here green PPT, chromium also green PPT. But what is the difference in the green precipitate? When we add an excess, the precipitate insoluble, precipitate does not dissolve. Whereas chromium, what happened? The precipitate are soluble or precipitate dissolve. So because in both cases the precipitate does not dissolve, that's why it should be iron 2 ion. So this is related to memorization for the ions. Which element is less reactive? So again, repeated question. Astatine group 7 element is less reactive than other members. And then septium, which is having an atomic number of 117, is a man-made and it is below astatine. What is the most expected state? So as you see, fluorine, chlorine are gas, bromine is liquid, iodine is solid. So what is the expected state for this septium? So what we expect that what will be the state? It won't be gas, it won't be liquid. So what it will be? It will be a solid, because when we go down, the melting point is increasing for group 7. So first two are gas, then liquid is there. So we expect it to be solid. So this is a periodic trend which you have to learn. Then question 25, whether balloons are filled with helium rather than hydrogen, because the helium is unreactive, does not react. And which is not the property of a group 1. They are soft and can be cut by a knife, that's true. They react when exposed to oxygen in air, they're highly reactive, that's also true. They produce acidic solution, that's strong. Because they are called alkali metals, so they produce alkaline solution. And they react rapidly with water, producing a hydrogen gas. So that is also true. So the wrong statement is C, that they don't produce acidic solution, they produce alkaline solutions. Four substances are there. This is again related to identification of the ions. When we add hydrochloric acid, a gas given off and give a lighted splint pop. So P is a metal. How we identify? Because metal plus acid give hydrogen. So P is a metal. A gas given off which turn lime water milky. So Q is a metal carbonate. Because when acid react with carbonate, it will give carbon dioxide which turn lime water milky. R and S, there is nothing given, so we don't know what are they. When we add sodium hydroxide, whenever a gas is given off, when we add sodium hydroxide, so it means this is ammonium salt. Because when ammonium salts are there, a salt which is having NH4, they have a characteristic that when alkali is added, they give off ammonia gas. And what about S? There is no reaction. So when we check, P should be a metal, so it can be A, B, C. Then Q should be a carbonate, so it can be A or C only, because, and R should be ammonium salt, so it cannot be C, it is only A. So then we are left with this option. That's why A is the right answer. So acid plus metal give hydrogen, acid plus metal carbonate give carbon dioxide. And alkali plus ammonium salts will give ammonia gas. Question 28. Which statement about transition element and their compound is correct? All transition elements have oxidation number +2. That's wrong. They have variable oxidation state. Aqueous solution of salt of transition element are generally colored. That is correct. Transition element change from metal to non-metal. That is wrong. Transition element can act as catalyst, but their compound cannot. That is wrong, because their compounds can also. So which statement is correct? B is the right statement. Then what is not the property of group 1? They are soft. Yeah, that's right. When they expose, they react with, but they don't form acidic solution, they form alkaline solution. You will find many repeated questions in this. So this question is also about identification of the ions.